So we're going to solve the equation, and all rational equations and radical equations you have to check for extraneous solutions, because sometimes you get solutions that don't actually work. They're like fake solutions or extra solutions. All right, so we have a rational function, x plus 6 divided by x minus 8 equals 0. So when you add and subtract fractions, that's the operation that's less fun because you have to have a common denominator. So whenever you're solving a rational equation, you need all of your fractions to have a common denominator. So the first thing you should do is just make it where it's obvious what the denominator is. So if there's not a denominator, put it over 1 so you can clearly see each denominator. And then we want to eliminate denominators. To eliminate them, you're going to take the entire equation and you're going to multiply it by the lowest common denominator, or LCD. So over to the side, you have to figure out what that is. The LCD, lowest common denominator. You figure out what that is by listing each unique denominator that is other than 1. Because all fractions have a denominator of 1, so we don't need to list that. So denominator 1, denominator x minus 8, so we need to list that. Denominator 1, so the lowest common denominator is going to be x minus 8. Sometimes it's more than that. So we're going to multiply this entire equation times x minus 8. Okay. So when I do that, take x minus 8, multiply it by the first term. It's x. So I have x times x minus 8. X times x minus 8. That was easy enough because I had a denominator of 1. Then I'm going to multiply x minus 8 times the second one. So when I do that, my x minus 8 in the denominator is going to cancel the one that I'm multiplying it by. Just to show you on this one, if I did x minus 8, because I multiplied it in the numerator, so then the denominator and the numerator will cancel, and all that's there is the 6. So this is going to be plus 6 equals, multiply it times the last piece. It's a 0. Anything times 0 is 0. So there I have eliminated the denominators. So I'm trying to solve this equation, so I need to get rid of the parentheses now. To do that, I'm going to distribute the x into the parentheses. And I get x squared minus 8x plus 6 is equal to 0. So I try to factor this. Normally when we have a quadratic, we're going to factor and solve. But this means I need to multiply to equal 6 and add to negative 8. But the only factors of 6 are 3 and 2, which 3 times 2 is 6, but that gives me 5 if I add them. Or 6 times 1, and 6 times 1 gives me 7. That's not 8. So this doesn't factor. Does not factor. All right, so there's two ways I could handle a quadratic that doesn't factor. One, I could use the quadratic formula. So quad formula. Or I could complete the square. So I know you guys already know the quadratic formula. I find it to be kind of a pain. I don't really like the quadratic formula very much. But completing the square it's a pretty simple process. And it works. It works for all types of factoring. You could do it instead of the regular factoring if you end up liking it. It doesn't matter. It's fine. So what you do is you take your quadratic and you have to find what I call the magic number. So for completing the square, you're going to need a magic number, which is just my name for it that I came up with. I don't know. It doesn't have a name. So you take the b value from your quadratic, and you're going to divide it by 2, and then you're going to square that. And that's going to give you what I'm calling your magic number. Okay? You're going to need that when you're solving with completing the square. But step 1 is do the opposite of what you do when you're solving a quadratic normally. Normally you want to get everything to one side so it's equal to 0. To complete the square, you want to take your c value and get it to the other side. You don't want the c value there. You want to get rid of it. So I'm going to subtract the 6 from both sides. So I have x squared minus 8x equals negative 6. Because I want a new c value, a c value that's going to make this really easy to work with, what I call the magic number. So you take the b, it doesn't matter if it's positive or negative because you're going to end up squaring it, so even if it's negative, it's going to become positive. So I'm taking the 8. 8 divided by 2 is 4. And then if you square 4, that's 16. So I'm going to say plus 16. It's my magic number, and you got to add it to both sides so that your equation stays balanced. As long as you add the same thing to both sides, it's fine. And now I'll factor it, because I just replaced the c value with a better c value. And you don't care how messy it gets on the right-hand side. Over here, it can get, it doesn't matter if it's nice and neat or if it's a mess. Whatever. It's not important. This side is what's important. So now if I want to factor this, every single time it's going to come up a factor squared. So when I factor it, I have my second sign is positive, so it tells me the two values are both going to be the same. And that one's negative, so they're both going to be negative. So I'm going to have x minus, and it's going to be squared. So if I multiply, what will I multiply by itself to get 16 and add to get to negative 8? It would be negative 4. So x minus 4, negative 4 times negative 4 gives me positive 16. Negative 4 minus 4 gives me negative 8. So this would factor to x minus 4 and the whole thing squared equals negative 6 plus 16. So it equals 10. And then we can continue and solve for x. So we factored it, and now we want to solve for x. So we're going to get rid of the squared by doing a square root. So now we have x minus 4 equals plus or minus the square root of 10, because we can't take the square root of 10. It's not a perfect square. Make sure you do plus or minus. Then we move over the 4. So that cancels. So now we have x equals 4 plus or minus the square root of 10. So potentially I have two answers. I have 4 plus the square root of 10, and I have 4 minus the square root of 10. If you did quadratic formula, you would get the same result. You would just have to do the formula and then simplify the radical. And it was a lot of work. In fact, I have it here if you want to take a look. Whenever you do quadratic formula, it's this. And I still got the same thing. And so if you want to stick with what you know using quadratic formula, that's fine. Because you get square root 40, and then you simplify it and reduce it. You can use whichever method you want.
Wait, can you put it back up?
Yes, I can. So you can use quadratic formula, or you can complete the square.
Yeah.
Okay, so then you want to check it. You have to check your answers. So check. we're going to check when x equals 4 plus the square root of 10. And we're checking into that original equation, which was x plus 6 over x minus 8 equals 0. So everywhere there's an x, I'm plugging in 4 plus square root 10. So it's parentheses 4 plus square root 10 plus 6 over an x, so parentheses 4 plus the square root of 10. Close the parentheses, minus 8 is still in the denominator. When you type this in your calculator, you have to make sure you have all your parentheses and all your values in the right spot. And it says this equals 0. So when I type it in, I end up getting that 0 equals 0. And yes, 0 equals 0, that's true. So this one checked. The positive version checks. Then you got to check the negative version. So 4, when x equals 4 minus the square root of 10, you have to do the same thing. Turn on ink. Again, you have parentheses, 4 minus the square root of 10 plus 6 over parentheses 4 minus the square root of 10 minus 8 in the denominator equals 0. Very carefully put it in your calculator with parentheses and everything in the right spot. You'll get 0 equals 0. So yes, that one works also. So this one checked. So then we know that is actually the answer. X equals plus or minus. X equals 4 plus or minus square root 10. Both of them, there's two solutions.